Alright, hello again. It's Elijah, and today you get the joy of seeing me mess up on the sketch pad here. So I'm just briefly going to go over a little derivation that I came up with, and I'm going to be referring to the sheet that Laskowski handed out Tuesday, April 9th in class. It's a little variable sheet here. And so in it, we have all the variables and then different equations here, and I added number 5 at the bottom. We can use the change in potential energy to find a particle's speed, and I came up with this equation right here. And so I'm going to show you how I derived that, and then leave a little copy of this sheet for you to download as a PDF. So let's get started. We start with our base KE equation. So it's KE is equal to 1/2 mv squared, like so. And from here, we want to isolate v without that square. So to start off, we can get rid of the 1/2 by multiplying both sides by 2. And so that leaves us with 2 KE equals m v to the second power. Alright, now to get v by itself, we divide both sides by m. And so we end up with 2 times the kinetic energy divided by m is going to equal v squared. So very simple. And from here, you should be able to see it's obvious that we take the square root of both sides, and we end up with v is equal to the square root of 2 KE over m. So with this in mind, we go back to our sheet. We don't have any equation to find KE here. All we know is this chunk at the bottom. If the change in PE is negative, PE is decreasing as it crosses over the delta V, and delta KE is increasing. And so you can kind of ignore that. Crosses over the delta V chunk. So if the change in potential energy is negative, PE is decreasing, which means kinetic energy is increasing. And if PE is positive, PE is increasing and kinetic energy is decreasing. And so we can see that kinetic energy is equal to the opposite of the change in potential energy. And I can symbolize that like so. That's okay. Gosh. So K is equal to the negative change in potential energy. You can kind of see what I'm saying here. So we can substitute KE in for this. And if I skip forward to where I've completed writing this equation, yeah, you can see that V is equal to the square root of 2 times the negative change in potential energy divided by m. M is equal to the mass. I know that isn't in the sheet right here in the variables, but I will add that probably just on this line right here. But yeah, so the equation looks a bit better down here. V is equal to 2 times the opposite of the change in potential energy. So if potential energy is negative, that means KE is positive. So we'll do negative PE, which comes out to positive. And if PE is positive, then KE will be negative. So the negative sign will overpower the positive sign, because that's how multiplication works. Divided by the mass of the charge or the particle or whatever you're looking for. And take the square root of all that, and you'll have your answer in meters per second, because that's how you find velocity. And if you have any questions, shoot me an email or text, whatever, leave a comment. Let me know if you have any issues. Alright, bye-bye.